Good afternoon. So today we are going to solve numerical examples on wedge friction. So what are these wedges? Wedges are the triangular or trapezoidal blocks which are used generally to support heavy loads by applying a relatively small force. These wedges are known as simple machines because of the friction between the wedge and the block or the body. These wedges will behave like a self-locking machines. For example, see this figure. Block B is supported by wedge A. The weight of B is 1500 Newton. So by applying force on this lower block A, which is known as wedge, you can maintain equilibrium of this block B. Even if you remove that force, the block B is not going to fall down because of the friction between these two bodies. Hence, it will act as a self-locking machine. Are you getting my point? So the practical applications of these wedges to lower or to lift heavy loads by applying a relatively smaller force. They are used. So please note down this example. Find the minimum horizontal force P to be applied on block A to keep block B in equilibrium. Weight of B is 1500 Newton. Weight of A is 500 Newton. The coefficient of static friction near the vertical surface and horizontal surface is 0.3. But the coefficient of friction between the two blocks is 0.2. This is the given figure. So you have to find out the minimum horizontal force to be applied on A to keep block B in equilibrium. Can you tell me what is the impending motion of block B? Because of this 1500 Newton, block B tends to move vertically downwards. So is the direction of impending motion. So when B is tending to move down, the block A, it tends to move towards left. Right? Now you have to apply this force P such that the B is impending its motion downwards and A is towards left for limiting equilibrium. That is the minimum force required to keep the system in equilibrium. Now, what about the friction forces? The friction forces will always act in the opposite direction of impending motion, right? So B is having contact with the vertical surface and also having contact with the surface of block A. So there is a friction near the contact surface. So near the vertical surface, the direction of friction force is vertically upwards, opposite to the direction of impending motion. Similarly, between the surface of A and B, the friction force here it is upwards. It is opposite to the direction of impending motion. Now, when you see block A, it is impending towards left. So the direction of friction force near horizontal surface, it is towards right. Whereas between A and B, near this surface, it is downwards. When two surfaces are in contact, so the friction force will act in the opposite direction at both the surfaces, having same magnitude to maintain equilibrium, right? So for B, if it is acting upwards up the plane, for A, the same magnitude of the friction force will act down the plane. Now let the normal reaction offered by this vertical surface on block B is N1. The normal reaction between A and B, I will call it as N2. And the normal reaction offered by the horizontal surface on block A as N3. Okay. So to start with, let us draw FBD of block B. So weight of B 1500 Newton. Normal reaction from vertical surface N1. Normal reaction from block A, I am calling it as N2. And the frictional forces near the vertical surface, it is upwards. Magnitude is coefficient of friction into normal reaction 0.3 N1. Whereas the friction force here, it is upwards. Magnitude is 0.2 N2. So the coefficient of static friction is 0.2. What are the directions of these normal reactions N2 with horizontal? It is given 75. Slope of this plane 90. So this will be 50. So N2 is making an angle 15 degrees with horizontal, whereas 0.N2 is making an angle 75 with horizontal. So let us write equations of equilibrium. Summation Fx is equal to 0. So N2 is making 15 with x. So x component is N2 cos 15 acting towards right. N2 cos 15. And 0.2 N2 is making 75 with x. So x component is cos 75, but the sense is it is towards left. Minus 0.2 N2 cos 75 minus N1 is equal to 0. So equation 1. And summation Fy is equal to 0. So by component of N2 upwards. So N2 sin 15. By component of 0.2 N2 positive. 0.2 N2 sin 75 minus 1500 plus 0.3 N1 is equal to 0. So solving these two equations, you can get the values of N1 and 2.
Sir, N1 is 1887.91.
And N2 is 2065.39.
N2 is how much? 2?
2065.54.
65.39. 65.3.
Right. Correct. So now next step is FBD of block A. Weight of block is 500 vertically downwards. Normal reaction from block B is N2. N2 is the normal reaction between A and B. When two bodies are in contact, each body will exert a reaction on the other with the same magnitude but opposite in direction. And a normal reaction offered by the horizontal surface N3. Applied force P. Frictional forces for A is tending to move towards left. So the friction force here it is towards right. Magnitude is 0.3 N3. Whereas here on the surface, the friction force is downwards. See, for B, near that surface, friction force is upwards. So for A, it must be downwards with the same magnitude. 0.2 N2. And what are the directions? We have this as 15 degrees, 75. So again, writing equations of equilibrium, summation fx0 plus p plus 0.3 N3. Please check the equations. Plus 0.2 N2 cos 75 minus N2 cos 15 is equal to 0. And summation Fy is equal to 0. Plus N3 minus 500 minus 0.2 N2 sin 75 minus N2 sin 15 is equal to 0. Solving equations 3 and 4, you can have N3 and P.
Sir, N3 is 6.
N3 is 1433.56 Newton.
And P is 1151.86.
No,
No, P.
1458.03.
Yes,
P is 1458.03.
Right. 14.
58.03.
Right. This is the right answer. Block A supports 750 Newton load and rests on wedge B as shown. Knowing that the coefficient of static friction at all surfaces of contact is 0.25, determine the smallest force P required to raise the block A. So what is the direction of impending motion? The smallest force P required to raise the block A.
Upward.
Right.
Upwards.
Block A is impending upwards, whereas block B
Leftward.
left.
Leftward.
Accordingly, you have to consider the direction of frictional forces. So this is the given figure. We know that block A is impending its motion.
Excuse me, sir.
And of block B is impending towards left. So the friction force for A, it is opposite to the direction of impending motion. So here it is downwards. Here the sloping surface also it is downwards. Whereas for B, here horizontal surface towards right, opposite to the direction of impending motion. And here it is upwards, opposite to this. So first FBD of A. See here, weight of the blocks not given. Okay, but there is an external force of 750 Newton acting. If weight is not given, simply you can neglect. See, if no external force is acting, even if the weight is not given, then you have to consider it as W. So applied force 750 Newton. I will consider this vertical surface. Here the normal reaction is N1 between the blocks A and B, N2, and from horizontal surface N3. So you have normal reaction, and from block B perpendicular to this plane N2. Now frictional forces. So here it is downwards. Magnitude is, coefficient of friction is 0.25 at all contact surfaces. N1. And for A, here the friction force is downwards. 0.25 N2. What are the angles? Directions 45 degrees. Right? It is given here. Slope of this plane is 45 degrees. So writing summation fx is equal to 0 plus N1 minus 0.25 N2 cos 45 minus N2 cos 45 is equal to 0. Summation Fy minus 0.25 N1 minus 750 minus 0.25 N2 sin 45 plus N2 sin 45 is equal to 0. So solving equations 1 and 2, you can have normal reactions N1 and N2.
Minus 882.32 and N2 is 998.33.
No,
Sir, N1 is 2136.28 and N2 is 2419.35.
right. So what is N1? 2?
136.28.
2136. N2?
2419.35.
Right. You have to be very careful with the calculations. Now let us draw FBD of wedge B. Applied force P horizontally towards left. Normal reaction from A is N2. Normal reaction from the ground N3. Frictional forces for B towards right 0.25 N3. Here it is up the plane 0.25 N2. See, for A, if it is down the plane, for B it is up the plane, having same magnitude opposite in direction. 45. So writing again equations of equilibrium. Summation fx0 n2 cos 45 plus 0.25 n2 cos 45 plus 0.25 n3 minus p is equal to 0. Summation fy minus n2 sin 45 plus 0.25 n2 sin 45 plus n3 is equal to 0. So solving these 3 and 4 equations, we have n3 and p.
And P is
2459.18.
What is n3?
Yes,
128.
128.3.24.
And p is
2459.18.
right.
2459.54.
Correct. So my answer is 2467 or 2459. It's okay. But here we are not using moment equation because we are treating these blocks as particles. See, the dimensions are not given. So if dimensions are not given, generally we will neglect the dimensions. Means we are treating them as a particle. Whatever the forces acting on the particle, all those forces will form a system of concurrent forces. So for concurrent force system, we have only 2 equations of equilibrium. Summation fx0 and summation fy0. Moment equation is not applicable. So we are not using moment equation because of 2 reasons. One is not required, because if you see the LBD of any figure, we have maximum 2 unknowns only, right? For to find out those 2 unknowns, 2 equations are sufficient. And the second reason is not applicable, being we are neglecting the dimensions. Then the next part and final part of friction is belt friction. You have one experiment on this, right? So you have to find out the coefficient of static friction between the belt and the drum. Now, here there
Excuse
are 2
me, sir.
figures. Yes.
Sir, will you please show that last slide, please, for 1 second? Thank you, sir.
See, here there are 2 figures. So in the first figure, let us assume that there is no friction between the belt and the drum. Whereas in second figure, there is a friction between the belt and the drum. Now, in the first case, on one side of the belt, suppose if 10 Newton force is applied. Now you tell me, how much force is required on the other side so that this side will be in impending motion? Means this side is about to slip, on the verge of slipping. So how much force is required? If there is no friction, yes,
10 Newton.
10 Newton, sir.
10.
because if it is less than 10, the left side will go down, it moves. If it is greater than 10, the right side will go down, it moves. But we want the condition of impending. That means we have to apply 10 Newton. Of course, this belt impends its motion on either side when it is 10 Newton, right? Now, what is the tension in the left hand side of the belt? It is 10 Newton from this point to this point. The tension in this belt is 10 Newton. And what is the tension in the right hand side of the belt? Again, it is 10 Newton. Means when there is no friction, the tension in the belt remains constant throughout its length. Is it clear? Now, in the second case, if there is a friction between the belt and the drum, on left hand side, 10 Newton force is applied. In order to impend the motion on right hand side, the force required will be less than 10 or is equal to 10 or greater than 10. If there is a friction, if you want to impend the motion this side,
Greater than
then
10.
Greater than 10.
it is
Greater than
greater
10.
Greater
10.
than 10.
Say for example, when 50 Newton force is applied, so this belt is about to slide down on the verge of slipping, but it is in equilibrium. Now at this stage, what is the tension in the left hand side of the belt, left hand side portion of the belt? 10 Newton, right? From this point to this point. Whereas the tension in the right hand side of the belt is 15 Newton. Am I right? So this 10 Newton side is known as slack side, and the tension is indicated by T1, and the other side in which there is an impending motion is known as tight side, where the tension is represented by T2. So T1 is the tension in the slack side, T2 is the tension in the tight side. What is tight side? It is the side in which there is an impending motion. So the tight side tension is always greater than the slack side tension, because in order to overcome the friction between the belt and the drum, so this T2 is greater. Say, at this point, the tension is 10 Newton and it is go on increasing. When it reaches here, it becomes 15. That means that extra 5 Newton force is required to overcome the friction between the belt and the drum, right? In order to overcome that friction, we need this 5 Newton extra force to impend the motion. And these two tensions, tight side tension and slack side tension, are related by the expression, what is that? T2 upon T1 is equal to E raised to mu beta. So this formula is to be remembered. What is T2? Tight side tension. What is tight side? It is the side in which there is an impending motion. T1 is slack side tension. Mu is coefficient of friction between the belt and the drum, whereas beta is the lap angle. It is the angle of contact of the belt with respect to the drum. In this particular case, what is the lap angle? 180 degrees or pi radians. So in the formula, here beta is lap angle in radians, remember. So this portion of the belt is in contact with the drum, making an angle pi radians with respect to the center, that is the lap angle. Suppose if the belt is passing over the drum for one complete turn. One complete turn. What is the lap angle here?
2 pi.
2 pi
2 pi
radians. Suppose this is
Sir,
the
and
shaft.
what is mu?
Mu is a coefficient of friction, static friction between
Yes.
the belt and the drum.
Yes.
So on one side, the belt is vertical. On the other side, the belt is horizontal. What is the lap angle?
Pi by 4.
5
Pi
by
by
2
2.
radians. Suppose if this horizontal portion is impending its motion, then the tension on this side you will take it as T2 and the tension on the other side as T1. Suppose here the upper portion of the belt is impending its motion, then the tension here it is to be taken as T2, on the other side it is T1. So the tension in the direction of impending motion is always right side tension, which is maximum. Okay, please note down this expression. T2 upon T1 is equal to e raised to mu beta. Note on this example. Determine the minimum coefficient of static friction between the rope and the fixed shaft shown in figure, which will prevent the unbalanced cylinders from moving. That means the system is in equilibrium. So what is the direction of impending motion? Obviously this 100 Newton cylinder
Right.
will tend to move downwards. So this cylinder tends to move downwards, whereas this 50 Newton cylinder tends to move upwards. So if you see the tensions in this row, so the tension in the direction of impending motion is T2. The other side tension is T1. T2 is always greater than T1. So here the value of T2 is 100 Newton. T1 is 50 Newton. Lap angle is how much?
Pi radian.
5 radians. So if you see from front, is 50 Newton cylinder, 100 Newton cylinder. So the lap angle is 5 radians. And the coefficient of friction is to be found. So using that relation, T2 upon T1 is equal to e raised to mu beta. You can find out mu.
That is 0.0955.
0.22.
0.220.
Right.
0.22. Yeah.
Now, for the same example, write down how many turns of the rope is required. How many turns of the rope are required to keep 6,000 Newton cylinder in equilibrium with a 50 Newton cylinder. Understood? So with the help of 50 Newton cylinder, you want to maintain 6,000 Newton cylinder in equilibrium. Means you are supporting 6,000 Newton cylinder with
Coefficient.
50 Newton. Coefficient of friction is this only, 0.22. Now, how many turns around the shaft of the rope is required? For that, what you have to do? You have to find out the lap angle. So now here T2 is 6,000. T1 is 50 Newton. Coefficient of friction is 0.22. So using that expression, find out the lap angle first. The number of turns
Sir,
is
3.
equal to total lap angle upon 2 pi radians. Because for one complete turn, that means 360 degrees, 2 pi radians. So total lap angle upon 2 pi, you will get the number of turns.
So 3.5.
Sir, 3.5.
3.5, yes, sir.
Are you sure?
Yes, sir.
3.5. Okay.
Yes, sir, 3.5.
3.46.
Right.
Mhm.
See, if it is of MCQ type, and if the options are given, say A is 3 turns, B is 4 turns, C is 6 turns, D is 8 turns. Then what is your answer?
4 turns.
4 is correct. 4 only.
B.
4.
4, sir.
Yeah, if it is the 3.5 means it has to be 3.5 or greater, then only it can support. If it is subjective type, you can write the answer as it is. But if it is MCQ type, you have to consider the higher digit. Okay. Now, so there is a sloping ground. Slope is 20 degrees. There is a tree over here. There is a car. Which is to be tied to the tree with the help of a rope. And the weight of the car is 200 kg. The coefficient of friction between this rope and the tree is 0.3. Okay. On the other side, a person is holding the rope. That means he is maintaining the position of the car by taking the help of the friction between the rope and the tree. And the number of turns of the rope around the tree is 2 turns. Are you following the statement?
Yes, sir.
Now, how much force is required to be applied on the rope by this man to maintain equilibrium of the car? That is the question. Minimum force required. Again, there is a condition. Minimum force required by the man to keep the car in equilibrium.
Sir, surface is frictionless.
Yes, if the surface between the car and this plane is frictionless, you can assume. Because here coefficient of friction is not given. That means you have to neglect the friction. So first you have to find out the tension in this portion of the rope. So that what you have to do. So this weight of the car, which is to be resolved into the components along the sloping surface perpendicular to this. So it is 20 degrees. W sine 20. So if you consider the rope and this tree, for minimum force required, that means it is impending in this direction only. The car is about to slip down and you are just holding to maintain equilibrium. That means the tension in the direction of impending motion T2 is W sine 20. T1 other side tension, that is the minimum force required. Coefficient of static friction is 0.3. Lap angle 2 turns, that is 2 into 2 pi, 4 pi radians. For one complete turn, 2 pi radians. For 2 turns, 4 pi radians. T2 upon T1. 200 into 9.81 sine 20 upon F is equal to e raised to mu is 0.3. Beta is 4 pi. Five 1
7. 1.57.
1.566.
right.